So we need to find the point on the x-axis that is equidistant from the following 2 points. One is 2, 3 and the other is -4, 1. Let's try to understand the problem graphically first. So here we have a Cartesian plane with the x and the y axis. So let's plot the point 2, 3. So we have 2, 3, so that's going to lie on the first quadrant. So this is the point 2, 3. We're going to name this coordinate point as A. Then we have the other point -4, 1. So we have to go 4 units along the negative x-axis and then 1 unit along the positive x-axis. So this is going to be the point B with coordinate -4, 1. Now in the problem, we have to find out a particular point on the y-axis which is equidistant from both the 2 points. Now let us suppose on the y-axis we take a random point C, and let's call the coordinate as 0, y, 0 because there is no x coordinate. And if we join point C and point A and also point C and point B, it's given in the problem that this length CB is going to be equals to the length AC. Fine. So this is given to us and we're going to label this as number 1. Now how do you find out the length CB or the length CA? All we have to do is use the distance formula. So if we have 2 points A and B whose coordinates are known, then we join them to find out the distance between the 2 points, which is a straight line, and that's given by this particular formula. AB equals to the square root of, underneath the square root, first we take the square of the difference of the x coordinate and then add it to the square of the difference of the y coordinate. Fine. So let's find out CB. So CB is going to be, first we'll have to take the square root, underneath the square root we'll have to take the difference of the x coordinate. So we'll start with the x coordinate of B, so that's -4, and from here we're going to subtract the x coordinate of C, so that's 0. So we have -4 minus 0 squared. Add it to the difference of the y coordinate, so we'll start with the y coordinate of B, so that's 1, and from it we subtract the y coordinate of C, so that's simply y, so 1 minus y whole square. This will be equals to AC. So what's AC? We'll take the square root. Underneath the square root, first we take the difference of the x coordinate, so we'll do 2 minus 0. We square it, and this must be added to the difference of the y coordinate squared. So we have 3 minus y, and then we're going to square it. So let's find out the value. So we have square root of, so -4 minus 0 squared, that's simply 16, plus if we expand 1 minus y whole square, so that's 1 minus 2y plus y squared. This value will be equals to, we have square root of, so 2 minus 0 squared, that's simply 2 squared, which is 4, plus expanding 3 minus y whole squared, we have 9 minus 6y plus y squared. That will be equals to, now we have square root of y squared minus 2y plus 17, that's equals to square root of y squared minus 6y plus 13. Now we can do is square both sides to get rid of the square root. So we get y squared minus 2y plus 17, that will be equals to y squared minus 6y plus 13. Now we can cancel out y squared for both sides. Let's transpose this -6y to the left hand side. So we have 6y minus 2y, that will be equals to 13 minus 17. So 6y, that's minus 2y, that's 4y. 4y will be equals to 13 minus 17, so that's positive 4. -4, so y will be equals to -1. So we finally find out the value y equals to -1. So that means our coordinate point will be 0, -1. So this is the point which is going to be equidistant from the point A 2, 3 as well as from point B -4, 1.